so now we're starting a whole new section. All right, and maybe one of these days I'll go through all the test questions that I gave you and separate them out into topics so that you know which ones you shouldn't be doing yet. I sent you an email at some point and said, people were panicking, how do I do this one? And I'm like, oh dear, yeah. You can't do it yet because we haven't done this yet. All right, so now we're bringing in the oracle. We've made some references to oracle along the way, but now we're going to do it more powerfully, right? So if you're proving A implies B, how do you do that? You go to the top of the mountain, you get an oracle, and the oracle is going to assure you of it, right? And so we kind of have two cases. We kind of skipped a lot of the Davis-Putnam things, but the slides are there if you want to go back and look at them. Basically, we're kind of branching on two cases, right? There's the case where alpha is true and the case where alpha is not true, right? And if it's false, then what do we know about this line? Right? If A is false, then A implies B is automatically true. So we don't have to worry about that. So, right? How do we know it's false? False because it's the case we're considering, right? And in this case, it implies it's true, right? So what about, oh, and it kind of makes sense, right? The lizard nurses its young, then the lizard's mammal, right? Is that statement true? Yeah, we want it to be true, right? So in this case, it works no matter what. Now, in the other case, right, we assume A is true. And why are we considering it true? It's because it's the case we're doing. Now, you might say, why am I doing this again? We've done this before. But people often come back and say, well, why are you assuming A is true? Well, only because it's the case we're considering, right? Right, and so then we have to prove B. All right, so you've all seen this is just purple table. Everybody good? And in this indent, we're assuming A. And if we're assuming A, then we have an oracle to help us. Another place we could get in, also when we were proving things, we wrote down here what we'd proven already. And here we're writing what we need to prove, right? So that separates. Down here, I'm the prover. I need to prove these things. And up here, I know they're true already. So I want to use the fact that they're true. So I'm going to have an oracle assure me that they're true, right? So that's just separates out the role of these people, right? And I think we did these slides already before. I threw them earlier, right? They were made here, but I threw them earlier to give you a warm-up. If I want to prove the and, I must prove both of them, right? And if I want to assume the and, if the oracle is assuring me of the and, then she assures me of both of them, right? If I want to prove the or, I get to choose which one to do, right? Right. So to prove, I might say to prove A or B, I'm going to prove B, right? So I might have cases, and in this case, I choose A. In this case, I choose B, right? So here, the problem is that she's assuring you of A or B. We don't know which one she's going to give us, right? And hence, what do we have to do? We have to look at the two cases, right? It's just the purple table. When we've proved already, we know A or B is true. You look at the purple table, how do you how do you use the fact that A or B is true? Well, one is proof by cases. You say if A is true, you go. If B is true, you go, right? So she's going to assure us of one of them, but we don't know which, right? So we can say in the case of A, we prove it. In the case of B, we prove it. Right? Everybody get that? Now, if I want to prove that there exists a girl, I construct the girl and prove that she loves. Right? We might write here, I construct the girl, right? Marilyn Monroe. Oops. What are you coming up? Something weird. This is what we need. Would anybody want to send email? Really, you can go away. You can go away. What? See, it's just not. Things aren't moving like they're supposed to. Like, yeah, I can't even get it to stay in goes in here and then it jumps out again. Well, here we are for a minute. Then it comes out again. Any idea? Could reboot the whole system again. All right, well, let's leave it in this form, because then maybe at least it's working at the moment. All right, so if I want to prove that there exists an object, then I construct it. And if I want to be assured that it exists, right? If the oracle is saying something exists, then she can give it to me, right? I can go up to the mountain and say, she says, I assure you that this girl exists. All right, who is it? Now, if I want to prove for all boys, then I get an adversary gives me an arbitrary boy, right? And I can say let B denote an arbitrary boy, and we continue to prove it, right? If she's assuring us that it's true for all boys, right, then anybody, the adversary or I, can give her a boy and she will assure it, right? Everybody, that makes sense? She says, for all boys, I say, yeah, tell me about Jeff, right? Oh, yeah, he's great, right? So here in the proof, we're assuming that for all boys. So then we can say, let B prime or B for all be the boy that, that we liked in our proof, and she'll assure us that it's true for that one. Right? Everybody good? So in this one, how do I prove it? I say I construct a girl, and then adversary gives me a boy, right? And why did I construct the girl first? Well, because I shouldn't know what needs to be a fixed girl. I can't know the adversary's boy, right? So again, she's going to give me a fixed girl, and then I get to give her a boy, right? Everybody see it's just the reverse game. Right? We know we've proved this already somehow, and so then we say let G be the girl, G exist be the girl that's defined to exist, and let B prime be something that we got in our proof, and look at it's true. Right? Everybody good with this game? In this case, we first get the adversary gives me a boy, right? And then knowing his boy, I get to come up with a girl, right? And in this case, the prover, the prover gets to give some boy, and she's going to find a matching girl. Right? Everybody get this game? And it seems pretty straightforward, and that's all there is, right? She's assuring us, yeah. Uh-huh. Yeah. Yeah, that's what, yeah. Just like we've been doing, if I want to prove there exists, then I say I construct it. If I want to prove for all, it's an arbitrary boy. Right? If I know for all, right? I've already proved for all, then I can say, hey, if it's true for all X, is it true for Jeff? And the oracle will say, yes, we know it's true for Jeff. Right? I mean, here I'm kind of writing how you might write it on a test, right? You've already proved this, right? If we've already proved this, then I can take any boy from anywhere, however I got it, and I can say, and then, right? Then we know it's true. If it's true for any boy, then for that boy we know that there exists a girl, right? So then I can say, well, let G prime be the one that exists. Yeah, yeah. If we're doing, so if we go over to the sort of the formal proofs, then you don't write the words, but it's the same, right? Here, I mean, the words help us to understand what's going on. All right, everybody good? And you'll see here, the G depends on right? The girl depends on the boy, right? So it's a function. Right? So in this case, the function. Why? The prover gives, here the prover gives some boy. Prover says Sam, and then the oracle says Beth. Right? Everybody kind of get this game? Right. So this is what we said before, right? She could fix the whole function ahead of time if she wanted to go first. Right? This is, again, I keep emphasizing the same thing over again. Right? Everybody get that? She could, for every boy, she could give me a girl, or she could tell me right off for every boy which girl it would be, and it's the same. Right? Everybody good? And the reason I keep doing this is because it's going to let us go to the formal proof. Right? So this is just being a little, why don't we say this, right? For every boy, then there's right? We don't want our function depend on the boy, right? I don't know. Right. So here's just the right. Do we need to do this? You want to do this more? We kind of, I think, kind of got it. So when we go over to our formal system, right? This means there's one fixed girl that works for every boy, right? And this line right here, if you have it as the line of your proof, it means there exists one function that's set for every boy. The function gives us the girl, right? People understand these lines? Everybody in the back? Are you asleep, people? All right. All right. So again, we have boys and girls are a problem, but right, you can have one universe of boys and girls. All right. So if we want to prove that this statement's not true in every, and this is where it's not true in every universe, right? So the oracle is giving us one universe, and then for it to be valid, it has to be true in every model, right? But clearly that's not the case. In the model where everybody hates, it's not true, right? So so now it's warming us up for assumption, right? In this case, we could have a fixed universe which we're given, right? And we can prove it's true in that fixed universe. Or we can try to say, is it true in every universe, right? In every model. Well, is it? No, if everybody hates, it's not true, right? So now we want to find a compromise between these, right? In fact, if I wanted to prove something about the integers, right, I can say over the integers, and now we know things about the integers. But the problem is, what do I know is true about the integers, right? We're trying to learn about the integers, so it's hard to know that we already know about them. So what we do is we write over here the things that we're assuming to be true about the integers, right? So we're going to say, assuming x plus y equals y plus x, right? Assuming these various laws, right? So here, we're not saying this statement is true in every universe, right? We're saying in every universe, if the left-hand side is true, then the right-hand side is true, right? Does that make sense? All right. All right, what does this statement says? This statement says, for every boy, for every girl, for every day, we just got love, right? There's just love everywhere, right? And if you don't know, this is John Lennon, who shot when I was about 16. All right, so with all this love, clearly the statement is valid. All right, everybody good with this? Yeah? Oh, no, just stretch. All right. But if it's for all universes, I guess I've been making universes green, but it's a for all universes, so the devil kind of gets to choose it, right? The devil gets to choose the worst case universe, and he gets to choose what objects there are, the values. He defines what love is. He defines any free here, any free variables, right? Day is not free yet, so that's a typo, but day is going to become free, right? Right? Green is for our models and our free variables. And then we want to play the following game, all right? So really, learn the game, right? Because if you don't know the game, you're going to fail, right? So just learn the game. All right, so what's the game? We have the prover proves the exists objects, right? The adversary tries to disprove it, does the for all statements. The oracle assumes things, right? Assures you of things, right? And right here, the prover asks help from the oracle. The adversary defines the model, right? Everybody good, right? So the adversary chooses the model, the prover, right? We think we've said all this already, right? So here, when we're trying to prove it, that the for all comes up, can we repeat this? You got the game?